Welcome to our class on Agromet-Humidity-Advances 2. Please subscribe to my channel, Agromet Farmers and Rural Development. Before we go into the class, I would like to say a small quote only to inspire you. Ethics is knowing the difference between what you have a right to do and what is right to do. According to Dalton's law of partial pressure, the condensation will create a particular saturation partial pressure known as saturation vapor pressure in general. In general, we call it as because a saturation vapor pressure is a function of temperature. Saturation vapor pressure is a function of temperature, and one should always conceive it as a function, nothing more than that. We should always conceive it as a function. When the concentration of water molecules surpasses the saturation concentration, more molecules will enter the surface than leaving it. Okay. Therefore, a net flux of water vapor molecules to the surface will occur. Flux means flow. So, a net flow of water vapor molecules to the surface will occur, creating condensation on the water surface. So, please go to the basics, what I have already uploaded. Okay, go to basics. There I have explained the process. Here, slowly we are going to the advances and applications. So, that's why I don't want to repeat once again. Now, so thus, if water vapor pressure in the air is slightly greater than saturation vapor pressure, condensation on flat pure water surface is expected. So this is what is the fundamental basics of what I told in the basics. Now there is some word called as supersaturation, which is hypothetical. Now let us see what is supersaturation. Supersaturation occurs when the vapor pressure and the concentration in the air is greater than saturation vapor pressure and concentration. Okay, this is only a hypothetical term. Supersaturation, nothing goes beyond 100, but still this term is there. Why? I will tell. So this may occur, this situation may occur when there are insufficient condensation nuclei on which water condenses. Condensation, for condensation, okay, for the condensation to occur, condensation nuclei are there. They are non-hygroscopic dust particles, dried leaves, okay, what not entering into the atmosphere acts as the sometimes sodium and chlorine. All these in the okay oceanic areas or sea areas you will find. So this may occur, okay, when there are insufficient condensation on which water condenses. By definition, saturation occurs when the relative humidity is 100% or 1. See, I have told several times the definition of relative humidity. It is the ratio between the amount of water vapor present in the atmosphere to the amount of water vapor required for saturation. Now, supersaturation, it is a hypothetical term. That's what I told in the previous slide. Supersaturation does occurs when the relative humidity is greater than 1 or 100%, which is hypothetical. However, go to first line of this slide. This may occur when there are insufficient condensation, okay, on which water condenses. This is what. Now, in the application point of view, a bit may come. That's why I am telling you several times. We are slowly entering into the humidity advances applications. So, in most cases, near the ground, when the relative humidity is close to 100%, condensation will occur naturally. The vapor pressure deficit is defined as the difference between the atmospheric vapor pressure and the saturation vapor pressure at that temperature. Now, so let us go to basics. What I told in the basics. Please go and then come to particularly on dew. Okay, I am going to give another presentation before till that. Try to understand that dew formation or condensation of water on a surface from the air above is only one way in which plants appear wet in the early morning. Lower humidity causes severe atmospheric drought. I told different types of droughts are there. Okay. Now in the basics, go to basics. Lower humidity causes severe atmospheric drought. High atmospheric humidity has several beneficial effects. Only one or two I will tell. In the basics I told. Once again, to just as a recapitulation, I am telling you first. Many plants can directly absorb moisture from the unsaturated area of high humidity. Right. Second, humidity may affect the photosynthesis of plant leaves. So most plants grow well on high atmospheric humidity except when saturated air persists for weeks, and completely stops the transpiration, which is generally impossible, right? So we here in this slide we are taking two crops. So how a variation in the humidity is causing some effects on the crop plant. For example, by varying relative humidity from 50 to 90%, it was found that the number of flowerings of groundnut increased with humidity. High humidity at night is especially beneficial. This is what I told. High humidity is beneficial at the nights. Of course, I don't want to go back into the basics. During the night time, respiration occurs. Whatever the photosynthesis or photosynthesis are regulated, in the night, if night temperatures are high, okay, they are consumed. So if high humidity is there, good for the crops. During the daytime, whatever the photosynthesis are there. So high humidity at night is especially beneficial because that high humidity won't allow much of the okay use of energy. That's why. So evapotranspiration decreases with increase in humidity. I told in the evaporation and condensation operation, transpiration, potential of transpiration, the basics. Please go to the basics and come back to this slide. So significantly higher rate of water use was reported at 40% of relative humidity than at 95% of relative humidity in the early stages of maize crop growth. So if you take the slide, okay, just how the relative water use efficiency in the basics I told. So during the dry summers, crops often exhibit a distinctly different growth response to showers. During the dry summers, crops often exhibit a distinctly different growth response to showers that are accompanied by a high humidity than they do irrigation that is accompanied with a low humidity. So it was established that other things being equal, the efficiency of water use increase with the humidity of air. Okay. Efficiency of water use efficiency we call it as okay. So basics I told once again. Thanks. See, kindly understand very simple thing. Uh, I would like to tell you a very simple thing. We are slowly going into the advances. Okay, one, two, three, four, five, like that. Why I am telling several times this thing is that there is a possibility for some bits in the JRF, SRF, even net interviews. Okay, that fundamentals slowly going into advances with the practical applications, which would be a combination of these three. Okay, that's why. So I would like to once again, okay, state that slowly we are going to advances. Thank you very much. Wait for next advances in the days to come.